All right, so we have this exponential function, f of x is equal to 3 to the x power, and we just want to sketch the graph of this guy. Okay. Now, once again, this is called an exponential function because the variable is in the exponent, right? This is very different than something like f of x is equal to x cubed, right? This is a polynomial function. Okay, so definitely you don't want to get these two mixed up. Okay. Now we can make a table, right? But definitely what I recommend is just getting a general idea, right, of what the graph of an exponential function looks like, okay? So, make sure you look it up or you use some graphing utility, right? But let's just draw a table first, okay? Let's make a table. Let's get some values of this guy. I'm going to call it y, right? We should call it f of x, but I'll just call it y in this case. So what happens when you plug in 0 here? Well, we get 3 to the 0 power, and anything to the 0 power is just 1. Okay? When you plug in a 1, we get 3 to the first power, which is 3. When you plug in 2, you get 3 to the second power, which is 9. And I guess we'll do one more, right? 3 to the third power is 3 times 3 times 3, which is 27. Okay, so these numbers, you notice the y values get larger and larger, right? They get exponentially larger, right? That's why it's called an exponential function. Can we plug in negative values of x here? Well, let's try it out, right? Okay, what happens when x is negative 1? You notice that this equals what? 3 to the negative first power. Well, wait a minute. What does that mean? What is 3 to the negative first power? Remember, that negative exponent tells you to flip or take the reciprocal of the base. What is the reciprocal of 3? Right, that's 1/3. And what happens when x is negative 2? Right, that's 3 to the negative second power, which is 1 over 3 to the second power, which is 1 over 9. So the exponent can be negative, right? All right, so what does the graph look like? And once again, my advice is get the general shape first, right? We should know what the general exponential function looks like, and then we should be able to apply it no matter what the base is, right? 3 to the x, 4 to the x, 5 to the x, it doesn't matter. The basic shape is going to be the same. So let's plot these guys, right? We got 0, 1. We got 1, 3, and we notice that, yeah, these y values are getting exponentially larger here, right? But what happens to these x values? Right? When x is negative 1, the y value is 1/3. Right? We get 1/9 here. And then these y values getting smaller and smaller and smaller. You notice that the y values will actually never equal 0, though, right? So we should actually never cross the x-axis, right? Because the y value is never going to actually equal 0. So this is our basic shape of an exponential function. It's not necessarily a U, okay? But you notice that there is some type of this is called the horizontal asymptote, right? This line just keeps going on forever to the left. Okay? For example, what do I mean by that, right? What if we plug in negative 100? Okay? Then what is the y value? It's 3 to the negative 100th power, right? Which is 1 over 3 to the 100th power, which is a really, really small number, right? But it's actually not equal to 0, but it's pretty small. Okay? So here, as we look at the graph that goes to the left, right? The y values get closer and closer to 0, but what happens here on the right side, right? As x gets larger here, the y values keep getting larger and larger, right? They keep going up, okay? So this is the graph of 3 dx. And basically, any exponential function should look generally like this. Okay? Now, we could do some horizontal or vertical shifting, or we could do some type of reflection or stretching, but every exponential function should look something like this.